13.2 microradians. That is the number the Uēkahuna tiltmeter at the summit of Kilauea recorded between April 23rd and the morning of May 3rd, 2026. 13.2 microradians of inflationary tilt. If you have never heard that measurement before, here is what it means in the plainest possible language. The ground at the summit of one of the most active volcanoes on Earth has been rising. Slowly, continuously, every hour of every day for 11 days. The magma chamber beneath Halemaʻumaʻu crater is being refilled from below, and as it fills, it pushes upward, and the surface of the ground above it rises in response at a rate of between 5 and 10 thousandths of a degree per hour. 5 to 10 thousandths of a degree. That is a movement so small that no human body could feel it. That is a movement only a tiltmeter can detect, which is exactly why the tiltmeters are there. And on the morning of May 3rd, the tiltmeter was recording what the Hawaii Volcano Observatory called a rapid return of inflationary tilt. Not gradual, rapid. And both Halemaʻumaʻu eruptive vents were glowing bright on the webcams overnight, and the south vent was producing intermittent heavy gas emissions, and the USGS forecast window for the next lava fountaining episode opened this morning, May 4th, 2026. Today. And simultaneously, 8,000 miles to the west in the central Philippines, PHIVOLCS, the Philippine Institute of Volcanology and Seismology, published a bulletin before dawn this morning placing Kanlaon Volcano's Negros Island on increased unrest status, recording up to 54 volcanic earthquakes in a single day in the preceding week, with sulfur dioxide emissions running between 1,100 and 2,098 tons per day, and ash plumes rising 1,200 meters above the summit on April 26th. The same Kanlaon that produced a 13,000-foot explosive eruption on April 8th. The same Kanlaon that has now been in continuous eruption since June 2024. 2 volcanoes. 2 archipelagos. One day. But that is not even the real story. Not even close. Because the real story is not the tiltmeter reading from this morning, or the forecast window that opened today, or the bright glow that the webcams caught on the south vent overnight. The real story is not episode 46 of the ongoing eruption of Kilauea, which is what the USGS is calling the next lava fountaining event when the summit finishes its current inflation cycle. The real story is what 45 episodes in 132 days tells us about the system that is producing them. About what a tiltmeter actually is, about what inflating means when the magma chamber beneath the most continuously active volcano on the surface of this planet is the thing doing the inflating. And about the specific gap between what the best instruments ever built to watch a volcano can measure and what those instruments cannot tell you, which is the one piece of information that actually matters when the ground above a magma chamber is swelling. Start with the geography. Kilauea sits on the southeastern flank of the big island of Hawaii, the youngest island in the Hawaiian chain, still actively growing, still in the process of becoming. It is a shield volcano, which means it builds itself not through explosive eruption of thick, gas-rich lava, but through the continuous effusion of thin, fast-moving basaltic flows that spread outward in all directions over geological time and construct a broad, gently sloping mountain that looks from a distance less like the archetypal volcano cone of a child's drawing and more like an enormous shield lying face down on the ocean floor. Its summit caldera, Pele, is roughly 3 kilometers across and contains within it the pit crater of Halemaʻumaʻu, which is where the current eruption has been occurring since December 23, 2024. Within Halemaʻumaʻu, from 2 vents separated by a distance that camera imagery shows as deceptively modest, lava has been fountaining in episodes that each last between 8 hours and 8 days, filling the crater floor with fresh basalt, building a cone around the primary vent that now reaches 45 meters above its surroundings, and accumulating a total lava volume through the first 43 episodes of 253.5 million cubic meters. That is 67 billion gallons of lava deposited inside the crater of Kilauea since December 2024 alone. The average lava depth across the crater floor is now 82 meters. The maximum thickness in some locations reaches 160 meters. The crater is being filled in front of real-time cameras that anyone on Earth can watch on the USGS YouTube channel, slowly, episode by episode, like a bowl being filled with something that was previously stored somewhere under your feet. The tiltmeter records it all. And the tiltmeter is the instrument that makes this eruption unlike almost any other in recorded volcanic history. Let me explain what it actually measures, because the word tiltmeter sounds technical, but the concept is not. The Uēkahuna tiltmeter, installed at the USGS Hawaii Volcano Observatory on the rim of Kilauea's caldera, measures the angle of the ground surface relative to horizontal with extraordinary precision. When magma fills the chamber below, the rock above bends upward, like a lid being pushed from beneath. The tiltmeter detects that bending as a change in angle, measured in microradians. When lava fountain begins and the magma erupts, the chamber partially empties, the pressure decreases, and the ground above deflates, tilting back toward its resting angle. During episode 45, which occurred on April 23rd, the tilt meter recorded 16 microradians of deflationary tilt as the magma erupted. Since the end of episode 45, it has recorded 13.2 microradians of inflationary tilt as the chamber refills. The threshold that typically triggers an episode is roughly the same tilt level the summit had reached before the previous eruption. That means the chamber needs to refill to approximately where it was when episode 45 began. It is currently 3 microradians short of that. It is filling at 5 to 10 thousandths of a degree per hour, and the forecast window for episode 46 opened this morning, and the window runs through Thursday, May 7th. This means the USGS Hawaiian Volcano Observatory is watching a clock. Not a precise digital clock with a countdown, a geological clock, one measured in the accumulation of pressure beneath a volcanic summit, in the angle of ground tilt recorded by a sensor on a caldera rim, in the brightness of glow from 2 vents that overnight showed what the HVO described as consistent bright glow, frequent bursts of flames, and intermittent heavy gas emissions from the south vent. All of these are symptoms. All of them are the tilt meter in different languages. The ground swells. The glow brightens. The gas emissions increase. The tremor pulses. And then the lava rises to the surface and fountains into a crater that is already full of the lava from 45 previous episodes. The tilt meter does not announce when. It announces that it is coming. Now understand what 45 episodes in 132 days actually represents in the context of Kilauea's recorded history. The current eruptive period began on December 23, 2024. That makes it 531 days of ongoing eruption as of today, May 4, 2026. In that time, 45 episodes have produced lava fountaining events, separated by pauses ranging from less than 24 hours to 3 weeks. The episodic pattern has remained remarkably consistent across those 45 events, each one following the same inflation-deflation tiltmeter signature, each one producing fountaining that peaks between 1 and 2 hours after onset, and typically reaches 500 to 1,500 feet above the vent at maximum intensity. Episode 43, on March 10th, produced lava fountains that reached 1,300 feet, approximately the height of the Empire State Building. Episode 44, on April 9th, reached 800 feet and spread tephra, which is the volcanic ash and glass fragments, including the fine threads of volcanic glass called Pele's hair, across communities to the northeast in the districts of Kau, Puna, South Hilo, and North Hilo. People in those communities found Pele's hair on their cars, their windowsills, their gardens. Episode 45 on April 23rd reached 900 feet and lasted from 1:34 in the morning until 10:01, nearly 9 hours of continuous lava fountaining from the north vent, with small particles reported in communities to the southwest. Now the summit is refilling. The tilt meter is measuring the refill. The south vent is glowing bright and producing flames in the dark. And the forecast window opened this morning. There are approximately 11,000 residents in the town of Volcano, Hawaii, and the communities of the Upper East Rift Zone within a few kilometers of the summit caldera. They live at an elevation of roughly 3,700 feet in the mist and tree ferns of the Upper Big Island. When episode 43 erupted on March 10th, the same day that the first Kona low began striking the Hawaiian archipelago, they watched lava fountains wind 300 feet high from the viewpoints at Hawaii Volcanoes National Park. They watched fragments of volcanic rock, glassy shards, and Pele's hair rain down on their cars and their rooftops. At the Wahikuna overlook, 4 to 7 inches of tephra accumulated. At Kilauea military camp, pieces of volcanic rock 4 to 5 inches across covered the ground. In Hilo, 18 miles from the summit, residents found Pele's hair on their windowsills. These are not numbers. These are the material consequences of an eruption that was inside the crater, contained within the national park, producing no lava flows that threatened structures, classified by the USGS at alert level watch, aviation color code, orange. That is the contained version. That is the summit within the caldera version. That is 45 episodes in, the version scientists can forecast within a window of days, the version where the tiltmeter gives enough advance signal that the USGS can publish a forecast window publicly on their website, updated daily, readable by anyone. The current alert level is advisory. Aviation color code yellow. The eruption is paused. The next episode is forecast for this week, and this is where the historical anchor of this story becomes the most important thing in it. Because what is happening at Kilauea's summit right now, the episodic lava fountaining within Halemaʻumaʻu crater, the predictable inflation and deflation cycles, the webcam footage of glowing vents and lava channels filling the crater floor, all of it is happening in the same place, above the same magma system, through the same plumbing, that in the spring of 2018 did something entirely different. Something the tiltmeter did not fully anticipate. Something that erased 3 communities from the map. April 30th, 2018. The cone of Pu'u'o'o on Kilauea's East Rift Zone collapsed. Not the summit. The rift zone, magma that had been stored underground, migrated downrift into the lower Puna region on the southeastern coast of the Big Island. On May 3, 2018, new fissures broke open inside Leilani Estates, a residential subdivision. Not in the national park, not inside a closed caldera. In a neighborhood, a fissure opened in someone's backyard and began erupting lava. Then another fissure, then another. 24 fissures in total. Lava moving at 26,000 gallons per second at peak activity. 60,000 earthquakes over the course of the eruption, including a magnitude 6.9 that was the largest on the island in 43 years. A summit ash plume that reached 30,000 feet, high enough to threaten commercial aviation. 716 homes destroyed. 3,000 residents displaced. 50 kilometers of public roads covered. Entire named communities. Kapoho Vacation Land, Lanapuna Gardens, Kapoho Beach Lots, buried under lava that ranged from 5 to 15 meters thick across most of the flow field and reached 55 to 280 meters thick near the coast, where it entered the ocean and built more than 875 acres of new land. The total recovery cost exceeded $800 million, and no one died. No one died because the county civil defense administrator went door to door. Because the USGS had issued a public statement in the weeks preceding the eruption that pressure was increasing and the volcano could be moving toward a change in behavior. Because the evacuation was ordered and followed, and the narrow window between the first fissures opening and the lava reaching residential streets was not closed by a community that had been given no warning. No one died because of the monitoring infrastructure and the emergency response and the community readiness. But the houses were gone. The communities were gone. The physical landscape of Lower Puna was permanently altered, and 14 square miles of it became the newest surface on Earth, covered in lava that is still cooling in places, still being mapped, still being integrated into the geography of an island that has been doing this, according to its own geological record, for the entirety of human habitation. 90% of Kilauea's surface has been repaved by new lava in just the last 1,100 years. Not in its geological history. In the last 1,100 years, Kilauea is not a volcano that periodically erupts and then rests. It is a volcano that is continuously building. Its lava has covered more than 60% of the Big Island's surface. The USGS describes its threat potential as very high, the classification given by the National Volcano Early Warning System, which evaluates volcanoes based on activity level, proximity to population, aviation hazard, and eruption frequency. Very high is the top of the 5-level scale. Kilauea's Niveau score earned that classification before the current eruptive period began, and the current period has done nothing to lower it. The current eruptive period, the 45 episodes since December 23, 2024, is all happening within the closed area of Hawaii Volcanoes National Park. All lava flows have stayed within the caldera. The hazards to people have been limited to VOG, the volcanic air pollution produced when sulfur dioxide reacts with atmospheric moisture to create a fine aerosol that can cause respiratory problems, and tephra, the Pele's hair and volcanic ash and rock fragments that wind carries downwind into communities near and far from the summit. Both of those hazards are real and persistent. Sulfur dioxide emissions, even during eruptive pauses, are running between 1,000 and 5,000 tons per day, according to HVO's own published estimates. During active lava fountaining, those emissions are higher. And several summit tiltmeter stations that would provide additional data remain offline as of this morning because the tephra field south of the caldera is too deep for technicians to safely cross to reach them. The same eruption that the instruments are trying to monitor has buried the access routes to some of those instruments. The monitoring is functioning. The monitoring is also operating with less than its full complement of sensors, because the eruption has physically disrupted the infrastructure built to watch it. This is not a crisis, it is a constraint. Detection is possible. The forecast window is real. The tiltmeter is working. What the tiltmeter cannot provide is the specific hour, and what the forecast window cannot tell you is whether episode 46 will behave like episode 45, a contained 9-hour fountaining event within the caldera that spreads Pele's hair on people's windowsills, or like the beginning of something the tiltmeter cannot predict until it is already happening. The history of this volcano contains both of those things. It contains 45 contained episodes in a row. It also contains 2018. It contains the 1960 eruption that destroyed the community of Kapoho. It contains the 1983 eruption that began the 35-year-long Pu'o'o eruption that eventually destroyed Royal Gardens subdivision. It contains 1,000 years of repaving its own surface. The tiltmeter measures what the system is doing. It does not measure which of the system's available behaviors it is selecting next. Think now about what produces these eruptions and why this island sits above a volcanic system of this intensity and persistence. Hawaii is not on the Ring of Fire. It is not above a subduction zone. There are no tectonic plate boundaries beneath the Hawaiian archipelago. What Hawaii sits above is a mantle plume, a column of superheated material rising from deep within the Earth's interior, possibly from the core mantle boundary nearly 3,000 kilometers below the surface, pushing upward through the lithosphere in a fixed location while the Pacific Plate moves above it. The Pacific Plate drifts at about 7 to 9 centimeters per year toward the northwest, and as it moves, the The plume burns a successive series of holes through its base, building each new island in turn, aging the existing islands as they drift away from the heat source, and constantly adding new volcanic rock to the youngest expression of the chain. The Big Island of Hawaii is the youngest island. Kilauea is the youngest and most active volcano on the Big Island. And the mantle plume beneath it has been building these islands for 70 million years, through every mass extinction, through every ice age, through the entirety of human evolution, continuously and without interruption. The geological record of Kilauea is a record of what this kind of persistence looks like across time scales the human mind struggles to hold. For approximately 300 years between 1510 and 1790, Kilauea was in a period of explosive eruptions so intense that it deposited tephra layers across large swaths of the Big Island, tephra that geologists later found preserved in archaeological sites, in soil cores, in the very ground beneath the roads and farms and subdivisions of modern Hawaii. The Hawaiian oral tradition of that period describes events of extraordinary violence. The Kanakakoi tephra, named for the cave quarry it buried, preserves those eruptions in chemistry and physics, in grain size and deposition angle, in the elemental record of a volcano that spent 300 years producing the kind of energy that today's episodic summit eruptions do not approach. After 1790, Kilauea shifted to the more effusive, lower-energy eruption style that has characterized its modern behavior. That shift is not permanent. It is a phase. And the phases of Kilauea are measured in centuries. The current eruptive period, 45 episodes since December 23, 2024, is happening within one of the volcano's quieter expression modes. Summit caldera filling, episodic lava fountaining, predictable tiltmeter cycles, but Kilauea does not stay in any one mode. It migrated from summit eruption to rift zone eruption in 2018, without the tiltmeter providing a reliable forecast window for when the migration would occur. It has erupted from its Middle East rift zone for 35 years continuously between 1983 and 2018. It has erupted from its lower East Rift Zone in the communities where people live in 1955, 1960, 1961, and 2018. A peer-reviewed paper published in Nature Communications described the situation with language that is worth sitting with. On short timescales, there has been no way to predict the timing and exact location of lava-producing eruptions from the lower East Rift Zone. However, on a scale of decades, potentially damaging eruptions are unavoidable. Unavoidable, not unlikely. Not low probability. Unavoidable. Because the system is continuous and the rift zone is charged, and the population of Lower Puna that built itself in the decades of quiet between 1961 and 2018 was building on ground that the volcano's own hazard maps had placed in Lava Zone 1, the highest hazard classification, a classification that was on the publicly available USGS map when every house in the subdivision was constructed. The low land prices of Lower Puna in the 1970s and 1980s were themselves the capitalized value of the volcanic risk, the market's way of encoding into every sale price the information that this land has been covered by lava before and will be covered by lava again. And 3,000 people bought that land anyway and built their lives on it anyway and woke up on May 3rd, 2018 to find fissures opening in their neighborhoods because the long pause between 1961 and 2018 felt in the way that all geological pauses feel to human beings living inside them, like safety. Now consider the additional signal from Kanlaon. The bulletin published this morning, May 4th, 2026, places Kanlaon at Alert Level 2, Increased Unrest. The Smithsonian Global Volcanism Program's most recent weekly summary, covering April 22nd through 29th, documents 7 to 54 daily volcanic earthquakes at Kanlaon, 2 to 5 daily periods of volcanic tremor, sulfur dioxide emissions between 1,162 and 2,098 tons per day, and 2 to 11 daily periods of ash emissions each day, with plumes visible rising 300 to 1,800 meters above the summit. On April 24th, a plume rose 800 meters. On April 26th, 1,200 meters. On April 25th, 300 meters and drifting southwest. This is not a volcano on the verge of sleep. This is a volcano that has been producing multiple ash emissions every day, recording up to 54 volcanic earthquakes every 24 hours, emitting 2,000 tons of sulfur dioxide daily, and which produced its most recent major explosive eruption on April 8th of this year, less than 4 weeks ago. The PHIVOLCS bulletin this morning describes increased unrest. The volcano edifice is inflated. Entry into the 4-kilometer permanent danger zone remains strictly prohibited. Local government units have been advised to prepare communities within the pyroclastic density current hazard zone for possible evacuation. 2 volcanoes, 2 archipelagos, 2 monitoring agencies publishing bulletins this morning with language that carries the same weight in different technical vocabularies. Rapid inflationary tilt, strong glow, and a forecast window that opens today in Hawaii. Increased unrest, elevated seismicity, inflated edifice, and ash emissions daily in the Philippines. Neither of these is an emergency as of this morning. Both of them are a specific kind of warning that is harder to communicate than the word emergency because it does not have a siren attached to it. It has a tilt meter. It has an earthquake count. It has a forecast window and a bulletin. The language of measured scientific caution that says, with full accuracy, the system is building. The window is open. The next episode is coming. And that careful language, spoken by scientists who have watched this volcano produce 45 episodes in a row and who are watching the tilt meter climb toward the threshold it reached before each of those 45 times, carries a weight that the word warning alone does not. The HVO's daily update on May 3rd noted that the rapid return of inflationary tilt and strong glow from both Halemaʻumaʻu eruptive vents indicates that another lava fountaining episode is likely. That sentence is the product of 531 days of watching this system behave, of 45 data points of tilt meter inflation followed by eruption, of ground truth that no previous generation of volcanologists watching Kilauea had access to at this level of temporal resolution. They are not guessing. They are reading an instrument that has correctly preceded 45 consecutive lava fountaining events. The tilt meter has been right 45 times in a row. And this morning it is reading 13.2 microradians and climbing. There is a visitor at Hawaii Volcanoes National Park right now who came from the mainland to see the lava. She booked her trip during the forecast window that said episode 46 would occur between May 4th and May 7th, and she is standing at a viewing overlook on the rim of the caldera above Halemaʻumaʻu, watching the vents glow in the early light, and she does not know exactly when it will begin. Nobody does. Not the USGS scientists who have watched this 45 times, not the tilt meter operator reviewing the data, not the HVO duty scientist who issues the VONA the moment the eruption begins. And in Volcano Village, the community of roughly 2,000 people that sits on the eastern flank of the caldera at 3,700 feet elevation in the mist and tree ferns, people went to sleep last night with the south vent glowing on the webcam and the tilt meter recording its steady upward climb. They scraped Pele's hair off their cars after episode 43. They sealed their windows against the fog between episodes. They watched the USGS website the way people in hurricane zones watch the National Hurricane Center track, with the specific attention of people who live inside the forecast area rather than outside it. They have done this through 45 episodes. Most of them have now seen the fountains more times than they can count. And they will wake up one of these mornings, possibly this morning, possibly tomorrow morning, to the VONA notification on their phones, to the aviation color code flipping from yellow to orange, to the sound of the eruption itself carrying across the distance from the caldera, and they will know what it means. They have learned what it means through experience that no other community on Earth currently possesses in quite this concentration. What they have also learned, and what 2018 demonstrated to the families in Lower Puna who watched their neighborhoods disappear under lava, is that knowing what an eruption means at the summit and knowing what it means when the system decides to express itself somewhere other than the summit are two different kinds of knowledge. The summit eruption is predictable within a window. The rift zone eruption, the one that reaches the communities, the one that opens fissures and subdivisions, gives a different kind of warning at a different kind of timescale. And the same magma chamber that is currently producing 13.2 microradians of inflationary tilt in preparation for episode 46 is connected through the same plumbing to the same east rift zone that erupted in 2018. The current eruptive period has shown no signs of migrating to the rift zone. But every previous rift zone eruption in Kilauea's history was also preceded by a period of summit activity that showed no signs of what was about to change. Detection is possible. The forecast window is real. The tilt meter is working at 0.05 to 0.1 microradians per hour and climbing. And somewhere in the interval between that reading and the specific moment when the pressure beneath Halemaʻumaʻu exceeds the containment resistance of the lava crust above it, the summit of Kilauea will begin its 46th episode of lava fountaining since December 23, 2024. The fountains will rise between 500 and 1,500 feet above the vent within the first 2 hours. The seismographs will record the onset in real time. The VONA notice will transmit at the speed of light to aviation authorities across the Pacific. The webcams will show it. The tilt meter will record the deflation curve beginning, and 13.2 microradians will become 16, and the forecast window will close, and the word prediction will again mean what it meant for the 44 times before this one: accurate in the window, unknown in the hour. The magma beneath the summit of Kilauea is moving upward at its own pace. The tilt meter records its movement. The forecast window adjusts to it. And the mountain, which has been erupting and erupting again in the same caldera since December 2024, which built the ground beneath every road and house and farm on the Big Island over the millennia, which produced 26,000 gallons of lava per second in 2018 and covered 14 square miles with the result, which is currently emitting between 1,000 and 5,000 tons of sulfur dioxide into the Hawaiian atmosphere every day, even while its eruption is technically paused. That mountain does not consult the forecast window. It fills, and then it erupts. It has done this 45 times in 531 days. The tiltmeter is at 13.2 microradians this morning, climbing at a rapid rate. The window opened today. The 46th time is coming.